Hello everyone, this is Mob, and this is your Daily Dose of Genetics. Okay, let's talk epistasis. It's basically when you have two different genotypes that lead to the exact same phenotype. Oh, but don't confuse this with dominance. It's not the interaction between two different alleles at a loci. It's the interaction between two different genes.
What is epistasis?
Bob, is that you? What happened to you? Wait, let me take you through an example. Maybe it'll make more sense. Let's look at a typical dihybrid cross without epistasis. As you can see here, we usually get 4 different phenotypes in the 9:3:3:1 ratio. I created this pun pathway to help demonstrate an example of single dominant epistasis. In this pathway, we are going to imagine that the two genes represented in this dihybrid cross, along with their interactions with certain enzymes, determine what version of Bob is produced. So here we have 3 versions of Bob: Caveman Bob, Dr. Bob, and Hipster Bob. Going through the genetic possibilities, we can see that the genotypes with the dominant A alleles are stuck at Caveman Bob because the dominant A allele inhibits the function of enzyme 1. However, if the genotype has a recessive A allele and a dominant B allele, then we will produce Hipster Bob since the dominant B allele allows us to bypass enzyme 2. The only way to produce Dr. Bob is to have a recessive A and B allele. That way we can bypass enzyme 1, but we can't bypass enzyme 2. Well, let's consider another cross. This time, it's not a dihybrid cross. Looking at the Punnett square, we could see that without epistasis, we can expect to get an equal amount of each of these phenotypes. But I kind of want to know, what would happen to the phenotypical ratios if we ran this through our epistatic Bob pathway? Oh, well, look at that! The genotypes with the dominant A alleles are still stuck at Caveman Bob, and the genotypes with the recessive A alleles but dominant B alleles are still producing Hipster Bobs. So each genotype is still producing the same phenotype, but the ratios have changed. In our last cross, we had a 12:3:1 ratio of Caveman, Hipster, and Dr. Bobs. This time, we have an 8:4:4 ratio, meaning we have a better chance of producing a Dr. or Hipster Bob in this cross. I'm starting to like the chances of this cross a lot better than the last one. I hope those examples helped. Wait, Bob? Bob? I should probably go look for Bob. What happened to him? Oh God, Bob, did it have to be the recessive A allele and the one dominant B allele?
Hell yeah, man. Epistasis.
Well, these are the citations. Stay healthy and see you again very, very soon.